Stephen.
Yeah.
The answer.
Yeah, that's it. You know, just remember my name.
Okay. And what's John? Johah.
A-N.
Okay. Oh, it's the same. Okay.
Yeah.
The first.
Huh?
S is
Character.
capital.
No, not
John
important.
Small
Not
is-
important.
It's the same.
Yeah, for email address, it's not important. Not important. Okay. Did you guys watch the lesson you missed from last week?
I didn't.
Ah, how come?
It's really pretty busy last week.
Ah,
I
Okay.
did
a little only. Why didn't you watch the whole thing? You'll need to
And
watch the
today
whole
is
thing.
a festival in China as well.
No, okay. Well, you need. Yeah, okay, whatever.
And we
You-
watch that tonight.
You better. I hope so.
Yeah,
Okay, let's see. We're on to number 13, I think. Principle of moments. Yeah, that's what we're on. Okay, let's have a look here. You got pen and paper?
Yeah.
Okay. See, you'll have to get a notebook, obviously, at some point. Just for today, yeah, this is your first day, isn't it? What's your name? I forget. Oh, Khalifa, that's right, I remember now. Okay, principle of moments, single and double support. You can write that down, that's what I'm going to have a look at. Yes? Somewhere you would like to write? Thank you. Don't fall asleep. Thank you. Yeah. So what's with the new look? You've got a new hat. You've got a new hat.
It's not new.
Oh, it's not a new hat, okay. You have a new hat.
Yeah.
Is this the new? And you have a hat. You need a hat. You got one?
Yeah, I got one.
Yeah. Good. You all have hats. Good. Okay, so principle of moments now. Have you got that? No, not yet.
Yeah.
Now, continue. You have this title.
Yeah.
Okay. So there's not much to look at. So it's not a big one. Let's have a look at this picture here. So what would happen if equal but opposite forces are applied at the ends? So you have a piece of wood. And you put a force here and a force here. So these two should cancel because they're equal, right? So will this move?
Yeah.
Yeah, but it doesn't move up.
No.
It rotates, yeah. So we have the idea that it shouldn't move, but it actually does. The plank is moving, it's rotating, which is what you said there. So a turning force is making a turn. Now, we talked about turning forces already. Do you remember the definition? Turning force, remember the formula for turning force? What is it? No, delta P is impulse.
FD.
Force by distance, FD, yeah. If it's not turning, then it would be in equilibrium. I'll explain this now. So look, this looks like it's balanced, but it's not because it's turning, it's rotating. Okay. So if you want something to be in equilibrium, what that means is that. Well, no, it doesn't have to be just from the middle. It means the force here and the force here, they cancel. So the force up has to equal the force down. It also means the force right has to equal the force left. force left equals force right. But not only that, that's not enough. That's not enough, because here up equals down, but it's still turning. So you need one more, you need also to have the turning force clockwise equals the turning force anti-clockwise. That whatever force is making it turn this way should equal whatever the same force that makes it turn the other way. Then it can be balanced. Okay. So your way of balancing it was, you said maybe you could put two of these in the middle. So that would work. Then it's not turning. So just to be clear, equilibrium means you have three things. The total force is zero, meaning the force left equals the force right, the force up equals the force down, and the clockwise equals the anti-clockwise. That's what equilibrium means. Okay, so that's a word you definitely need to know. If you can write this whole box down, that would be great.
Forward is R.
Ah, you forgot!
What?
No. Force multiply distance.
No, it's last class.
Oh, we did it last class.
Yeah.
Oh.
It's the last class.
Oh, you see what happens now. Okay, so L is something called a turning force, and it makes it turn. And to calculate it, you do this distance multiplied by this force, and that's called a turning force. It's also called a moment.
So it's R.
I use the letter L, but you can also use this letter, tau.
R is better.
Yes, I think so. You really need to watch the video, okay? You really need to watch it. So if you can write this down. What Chinese festival is it?
Today's beginning of the February, I think, around 4th February.
But what's so
4th
great about it? Why is it special?
is the most important festival in China.
Yeah, why?
It's Spring Festival.
Oh, Spring Festival, okay,
It's like
New Year.
Christmas,
Yeah,
same.
yeah. Yeah.
And they like prepare for like small spring.
I understand, there is.
So what's L again?
Turning force.
L.
L, yeah. Also called moment. Yeah. So what happened, Khalifa, that delayed you getting here? You had visa trouble or something, was it?
Yeah, the visa troubled and
Something big or something small?
something big. I wanted flying to British Airways,
Yeah,
but they said I couldn't enter UK.
because of your visa.
Yes.
Oh.
So I have to reapply for Ethiopian Airline.
You have to reapply.
Yes.
Oh, that's a pain. So they wouldn't let you, whatever visa you had, they wouldn't let you go through the UK
Yes, but
to
I'm
get to Ireland.
Yeah, I'm going to apply for UK visa soon.
Yeah, okay. Yeah.
It's much better.
Yeah, well, especially if you want to study in the UK next year. Is that what you want to do?
Then
Don't know yet, yeah. No, it is useful to have a UK visa as well, yeah. Did you write this down? Yep. Okay. Continuing. So, well, I don't know, maybe you've studied this before, actually. Have you?
Yeah, I think so.
You think so? Have you seen this before? In high school?
This war?
This idea,
Oh,
the clockwise and anti-clockwise, yeah. The last one here is actually called the principle of moments, this last one here. So I think you should write this word down somewhere. This last one's called principle of moments.
Okay.
How come you're so tired? What's wrong with you?
I got up so earlier.
How early?
5 o'clock.
Why?
Because
So,
I moved.
That's too early, 5 o'clock, come on.
I guess I'm at 6.
That's okay.
Yeah, I moved to a new house.
Ah, I see, okay.
And I think it's a little bit far away.
Where is it?
It's Dublin 15.
15. What's Dublin 15?
In the just 22 kilometers.
Ah, that's no 22, no problem. You can cycle that.
Cycle.
Yeah, why not?
22. It's 66. No, sorry. 36 kilometer.
You're 30. Yes. Yeah, you would be 36, wouldn't you? Yeah. And he's like, wow, we're 22. Wow. Yeah, no problem. 22, easy. Okay. Continuing now.
Yeah.
So the last point is, you don't have to write this, that the clockwise equals the anti-clockwise. Okay. Right, so here is a simple example. We'll do this together. A 40-kilogram boy sits at the end of a 100-kilogram seesaw, and his sister, 30 kilograms, sits at the other end. And the pivot is in the center of the seesaw, and the seesaw is not balanced, so it rotates. So the father then decides to fix this by moving the pivot. So I'll just draw what's happening, okay? This is the picture. No. Ask me what word. What word do you need? Ah, you see? That was in the last class.
What's seesaw?
Shut up.
No, don't do this. Don't do this.
Yeah, I guess maybe it's that.
Yeah, it is that, okay. Here's the pivot.
Okay.
Okay. So you have the boy here and the girl here. But of course what happens, since the boy is heavier, it will turn this way and this. So what the father does is he moves the pivot to some place that will make it balanced. Okay? So boy here, girl here. Now we're told that he is 40 kilograms and she's 30. Yeah. And this seesaw is actually 100 kilograms. Okay? And that's actually important too. Because here, at what's called the center of gravity, there's the weight of the seesaw. There's also the weight of the boy and the weight of the girl. And there's one more force I didn't draw. What's that? 100G. Yeah, what's that called, Summer? Don't tell him. Come on, Summer. What's this one called? Yes? Yes?
What?
Read something.
Yeah. Something.
Don't tell him.
I don't know.
What? You don't know this? You should know this.
I know the first one. I don't know the word.
You should know the word. Do you know the word? Girls? Ah, that's terrible. Guys, this one is called the reaction.
Oh, reaction. Yeah. It's a reaction.
Terrible. Okay, so let's put in some distances here. So the distance from here to there, that's 2.5 meters. Because you're told it's a 5 meter seesaw. 5 meters. We'll call this distance here x to the pivot. And we don't know where this is. So what's this distance here?
5.
No?
2.5.
2.5
Minus.
minus x is that distance there. Okay. Our job now is to calculate x. So we'll take this as the turning point. The point where it turns. Okay? So looking at all these forces, this first one here, does this make the seesaw turn clockwise or anti-clockwise? Now, remember, clockwise means like the clock, like this way, and anti-clockwise is backwards. Okay. So is this one here clockwise or anti-clockwise? This one here is anti. This one here, this one clockwise or anti-clockwise?
Clockwise.
Yeah, it's trying to make it turn clockwise. And this one here tries to make it turn clockwise. Now what about this one?
Clockwise.
No,
Mm-mm.
it's stable, right?
Yeah, yeah. It does nothing. It does nothing because it passes through the pivot. So it has no effect to turn it. It can't turn it. You can't turn if the force is through the pivot. It's not possible. You have to be some distance away from it. Okay? So the principle of moments says that the anti-clockwise equals the clockwise. So that means this one here, force multiply distance, yeah, 40g, 9.8, yeah. It's weight. It's weight. 40gx should equal 2.5 minus x times 100g plus, now what's the distance from here to here? That's 2.5, 5 minus x. 5 minus x, and her weight, her force is 30g. Cancel, cancel, cancel. So you get here 40x equals 25? No. 250 minus 100x plus 600 minus 30x. So what's that? 170x is equal to 850. So the x is 850 over 170. So that's where the father should place it. What is it?
5.
Exactly 5?
Yeah, it's exactly 5.
5 is too big.
5 is too big.
Yeah, it should be less than 2.5. What's my mistake here? 2.5 minus 100x. 5 times
300.
5 times
100.
150, not 600. 150. Thank you. 100. So it's 150.
Is 400.
400. Okay, that's better. That's a 400.
2.3.
That's better. 4.
2.35.
2.35 meters. Yeah.
So we don't calculate reaction. It's not.
No, not necessary. And this one's not. So what did the father do? He moved the pivot 15 centimeters to the boy. Because remember I said at the start it was in the middle. So he must move it 15 centimeters to the left towards the boy. So that's the answer. He moved the pivot 15 centimeters left to the boy. Is that okay? Ben? Yeah? Somewhere?
Yeah,
Okay?
yeah.
Yeah, because it was,
Yeah.
It's not too difficult.
Yeah.
It's a short little question. So can you make sure you have this copied down?
Copy that.
Of course.
Of course. We don't need a question. No.
Well,
we
you
don't
can
need
you can write it if you like, but the picture's enough. Yeah. Seesaw, yes.
Oh yeah, it's see so.
Yes, I suppose so. I suppose so. Have you done, Khalifa, have you done this type of stuff before in high school?
Yes, we do that much.
Not that much?
Yes.
Yeah. But this is a sort of familiar topic?
Yes.
Yeah. Are you Nigerian?
Yes, I do.
Nigerian, yeah. So what do they call the secondary education in Nigeria? What's the certificate called?
Secondary school.
Yeah, but the like what's the name of the certificate at the end? Like it has a name, like the program, you know what I mean? I can't, like, is it WAEC?
WAG. Yeah.
Yeah.
WAG and NICO.
Yeah, that's the two in Nigeria, isn't it? Which one did you do?
WAG.
Is-
Boots. WAG and the NICO.
Yeah, okay, alright. And you do physics for both?
Yeah, I did.
Okay, good.
Second physics in my second upper year.
Mm-hmm.
That SS1, SS2 and SS3. Just for 2 years. Physics.
Okay. All in English, of course.
Yeah.
Yeah, okay. Right, have you got this?
Yeah.
Yeah? Okay. Here's another one. A 100-gram meter stick. Do you know what a meter stick is?
Yeah.
You know what it is, yeah. Now let's see if these guys know what it is. Do you know what a meter stick is? No?
I don't know.
Do you want to have a guess?
Like
Yes, like a ruler.
ruler
How big do you think it is?
meter.
Yes, correct. It's a 1 meter ruler. Okay? And it's 100 grams. And you hang it from 2 strings. And the first string is tied at 25 centimeters, and the second is tied at 90. So the picture looks like this. You have a meter stick, and there is 0 centimeters, and then at the end is marked off 100 centimeters. Yeah. And you have a string here, where was it? The first string is at 25, and then the second one is at 90. And by the way, where's the weight? Yeah, so that's at 50. Okay?
Yeah.
Now, the weight is 0.1 g. Yeah? And this we'll call T, and this we'll call S. And we want to find T and S. So in the last question we didn't find the reaction, but now we want to find these two. They're not called reactions. Does anyone know what they're called? Well, you probably know, so let's see if they know. They're not called reactions because it's a string. Do you know what the name of the force in a string?
Drag. No.
No, not drag, no.
What?
Not weight, no. If it's in a string. No. You call these tensions. If it's a string,
Oh.
it's called a tension.
Oh.
And if it's a table, it's called a reaction.
Oh
Yeah?
yeah.
Yeah? Yeah, okay. Right, so, is this moving? No. So it must be that T plus S equals the weight. So that's one equation. But we still need to make another equation. Is there any forces left and right? No.
No.
So there must be a turning force. Turning force. Now, the question is this. Where is the turning point? That is, where is the pivot? Where is the pivot?
The center?
So, okay, so we have one answer here. You're going for the center. Any other ideas? Let's see what people are thinking here. So you're going with the center. Yeah.
Maybe more right.
Where?
Like 90 minus 25 and divide.
Oh, I see. Okay, so like somewhere in here between the two. Okay.
No.
Like that's 60.
Between T and I's middle point between.
Oh, I
T
see,
and I.
exactly in the middle. So like here.
Yeah.
Yeah.
Yeah. Okay. Gotcha. Summer, what do you think?
My brain is stalled.
No ideas? No. No. Anybody thinks here? No? Here? Maybe here? This is the answer.
Where?
Everywhere. So you can use any point. You can use any point. And you'll get the same answer, which is very, very interesting. It's very, very interesting. So for example, if
Oh, yeah.
Khalifa took this as the turning point and calculated T and S, he would get the same answer as if you two took here as the turning point. You get the same answer,
Okay.
which is quite interesting.
Mm.
And this is only possible if it's in equilibrium. Well, not only possible, but if it's in equilibrium, there really isn't a turning point because it's not turning. If it's balanced, is it turning? No. So it means you could kind of put the turning point anywhere because it's not really,
moving.
it's not moving. It's not moving. Yeah. It's in equilibrium. It's balanced. So the real question now is, what would be the easiest point to use? If we can use any point, what would be the easiest point to use?
For it to move?
Say again, yeah?
For it to move?
No, just for calculations. Which would be the easiest equation to make for clockwise and anti-clockwise? Middle seems like it should be easy, shouldn't it? But there's a better point here. And the reason this is a good point to pick is because you don't have T. Because it's through the turning point. You only have this and this. This one is clockwise and this one anti-clockwise. So that distance there is 0.25 times 0.1 g. That should equal, what's that? 65? 0.65 times s. This one is clockwise and this one is anti-clockwise, and they should be equal. You don't seem happy with this. What's confusing you?
Why T is clockwise?
T?
T is it?
T isn't in this. T is through the pivot, so you don't care about it. No, you're not happy. You're very unhappy. You too, Ben and Summer. Khalifa, happy or unhappy with this? You're happy with this? Okay.
Okay. What?
You're okay.
Yeah.
I understand that's meaning, but why in the T is more easier? Why not put it in S?
Oh yeah, you can put it in S.
So it's the same.
Yeah. Just I wouldn't put it here.
So
Because
you
if you
don't
put
know-
it here, you'll have a T and an S in the equation.
Okay. Yeah.
Which is okay because you have T and S here.
Okay.
Yeah?
So we get the S.
You can get
and
S.
We get the T.
And you get the T.
So there's no problem.
So there's no problem.
Okay.
So it's easy. So what is the S here, please? Can someone tell me that? It would be 0.25 times 0.981 over 0.65.
.377.
Newtons. And here, remember, T plus S has to equal 0.981. So then what would T equal?
0.981 and 0.604.
Newtons. Now, I want to prove that you get the same answer even if you choose a different turning point, okay? So, if I took this as the turning point, yes, the middle, let's take the middle. So, I still have T plus S equals 0.1 g, but if I took the middle here, there's T, there's S, there's the weight. Is this clockwise or anti-clockwise? Clockwise. This one? Anti-clockwise. So, what's this distance here? That's 0.25. and this distance here, 0.4. Okay, so t times 0.25 should equal s times 0.4. Or you could just say 0.25t minus 0.4s equals 0. Okay? Let's solve this. How will we solve this? We'll multiply this by 4 to make that t.
Okay.
So we have t plus s equals 0.981, and then t minus 1.6s equals 0. You minus these, you get 2.6s equals 9.81. So what's 9.81 divided by 2.6? I think it's 0.377.
No.
Are you
Oh,
sure?
sorry.
Don't scare me.
2.6. Yeah.
Yeah. The same answer. The same answer. So it doesn't matter where you put the turning point, so you might as well pick an easy place.
你摁错了。
I know English. What did he do wrong?
Oh, sorry.
He just made a mistake.
Yeah.
Okay. So my tip is to choose the turning point that goes through one of the strings, because then you can get s quickly, and then you can get t quickly.
Less than.
Yeah. So short. This is usually a section A. Oh, don't worry, these are all going to be uploaded, so don't worry if you miss something then. Okay, so if you can write this one down, this
No,
is
you take the start point.
Huh?
Start point for
Start.
the vlog. Start point. Start.
Oh, did I hit start? I hope so. Yes, I did. It's been 32 minutes and 10 seconds. Yeah.
That's all.
Yeah, because you're not writing a lot, is it? Yeah.
S 0.25 bracket 0.98.
Hang on, where am I looking? S.
Yeah.
This here.
Yeah. So where did that 0.98?
In my head I just did 0.1 times g, and for this course g's value is 9.81.
Okay.
Yeah. I don't know what you used back home.
Yeah.
Did you use 9.8 or 10 or something?
10.
10, okay, yeah. Which calculator do you have, or do you not have one yet?
No, I just invested this. I'll buy everything today.
Yeah. Try to get one like this.
Science one, right?
Yeah, but like this one.
Okay. I'll just take a look.
Yeah. If the best one for this course is Casio 991. That's the best one.
Okay.
That's Cassie.
Yeah, but is it Casio 991? No.
It's Tesco.
And that's Tesco brand, yeah.
That's 9-1. Oh.
No, that's not 991, but it's okay.
I like one.
It's the best one.
I will search.
Yeah.
You don't need to buy them.
That's a terrible calculator.
Yeah, it's really terrible calculator.
Yeah. Okay. You have that? Can we scroll on? Yeah. I don't know if there's more examples. Let me see if that's it.
Okay.
Yeah, there's one more example, but it's kind of like the other two. I don't really feel like it's so important to do. How are we doing for time? Yeah, I don't think you need to see this one. It's another example that's kind of like this.
Hello, is this one?
Let's see. Yes. This.
Yes. I haven't saw this kind of calculator.
This one looks like it would be good.
Oh.
This one looks a bit better than this one. Why? How much is it?
What?
How much is it?
How much?
Maybe it's 20 euro.
Yeah, sounds about right.
Yeah.
You don't have to get that one. That's the best one. But that one there is very good, what Ben has. You got that from Tesco, didn't you?
Yeah, just these two and like just between.
You picked the right one. You picked the right one.
But
Yeah.
when we go to the Tesco together,
It's gone.
yeah,
It's gone.
sold out.
He bought the last one.
Yeah.
Yes.
maybe.
Okay, so let's see how many questions you have. You can just try these for a couple of minutes. Yeah. These questions aren't so big.
So big.
Yeah, they're not so big.
What's big?
What's big?
B-I-G.
Big.
Big.
I mean, is the answer big or
Ah! The time.
time?
The time is small.
Oh.
You don't need a lot of time. You need a little time.
Oh.
Do you know what I want? What I want you to do now is you should finish this at home, but for right now, just do question 3 for me. Question 3, and then once you finish question 3, we'll look at the next lesson. Wait, hang on, no, I have a better idea. Wait. Question 3 is the meter stick.
Yeah.
Yeah. I'm going to tell you where to put the turning point. Okay? So, I'll tell you where to put the turning point. I want you all to do it differently and get the same answer. So, Summer,
Yeah.
listen. I want you in number 3 to put the turning point at 0.
At 0.
Yeah. Wait, Ben? I want you to put your turning point at 10.
Okay.
Go. Yours can be 80 centimetres.
Okay. Sorry.
And Khalifa, yeah, your turning point at 100 centimetres at the end of the meter stick. Yeah. So you all should get the same answer.
Okay. Okay, no problem. Let me think.
Did you get an answer, Ben?
Yes.
What did you get?
0.56.
And correct. Good job. Good job.
Also, I'm the easy one.
You had an easy one, yeah. That's true. That's true.
Maybe you can try this.
No, he has to use the turning point at 0.
No, I know this.
I smelled earlier. Yeah.
Are you sick, Summer?
No, I'm not sick. I just tired.
Exhausted.
Exhausted.
Exhausted, yeah. Khalifa, did you get an answer? Yeah, that's fine, yeah. You had the easy part then. Okay, Summer and Khalifa, if you can't get the answer, you can change the turning point.
No.
Okay, fine.
I need this.
Fine. Did you have maths today?
No.
Chemistry?
Yeah.
What are you doing in chemistry?
Listening.
Good. Listening to what?
New vocabulary.
Good.
And yeah, that's it.
You okay, Summer?
Yeah, I'm okay.
Going very slowly.
I'm okay.
Alright. He has no energy. See how tired he is.
But I think he has a nice lunch.
No.
No.
Oh yeah, you and Gao were sick last week from your hot pots.
Sick
You were sick last week
last week. Yeah, I see.
because of your hot pot.
Yeah.
Too spicy.
No, it's too much.
Too much. Yeah. Too much food?
Mm-hmm.
It made you sick.
I think stomachache and company.
Yeah.
I mean, and follow with headache.
Headache?
Yeah.
My goodness.
So I don't know what happened.
My goodness.
But not better.
Oh. Gao was the same?
No.
Oh, okay. You got it, Summer? You got it, Khalifa.
What's the answer?
Well, what did you get, Khalifa?
1.12.
No. I think it was 0 point something.
I see.
Yeah.
Correct.
Summer, get an answer.
I'm trying. The S
Yeah.
is
No.
0.014.
0.014.
I think it's too small.
Yeah, I think so too. What? 0 point.
Maybe is wrong.
No, not maybe. It is wrong.
Yeah. But I think I just need the S. But in the terms cm,
Yeah.
there is a force,
Yeah.
and in the 80
Yeah.
cm
Force.
there is force.
Yeah.
But my turning point is in the 0.
Yeah. So you have two equations.
Yeah.
You have t plus s
Yeah.
equals
0.
0.981.
Yeah.
Yeah.
And 1t is 0. Sorry, 1t is 0.1 g.
Multiply.
Multiply 0.1.
Yeah. Yeah.
And, equals the
0.8.
I think it's 0.77.
0.77.
Oh, so sorry. I know where is my wrong?
That's mine.
You got what?
0.14.
0.14?
Yeah.
I don't know. Is that what you got, Ben? 0.14?
No.
No, not this.
0, 1, 0, 0. Yeah.
Is that not moving?
Not moving.
Okay. Which tension?
I want both.
Okay.
This guy here and this guy here don't have it yet. Only this guy has it.
Okay.
But my answer is the S.
Yes?
The S is
Yes? What is it?
0.0.
Yes? No.
Why?
Oh, Summer
Why?
Khalifa.
Why? I think.
Did you get it? No. I'm going to show you. So, have a look. So for Summer one, I asked Summer to place the pivot here.
Yeah.
Okay, so far, Summer?
Yeah.
Right, where's the first strain?
In that.
At 10, is it?
Yeah.
10 centimetres.
Yeah.
And the second one?
80.
80 centimetres. Okay.
Yeah.
And the weight?
Is
At 50.
Yeah.
Yeah. And this is T, S, and 0.1 G.
Yeah.
So Summer, did you say T plus S equals 0.981?
Yeah.
Good. I hope so.
Yeah.
Now, this one here, so Khalifa, your one will look like this, except your turning point would be at this end. Something different. Clockwise or anti-clockwise? The T. Is it making it turn anti-clockwise or clockwise?
Clockwise.
Anti-clockwise.
Oh.
And this one? Clockwise. And this one? Anti-clockwise. So, you should have 0.5 times 0.1 G should equal 0.1 T plus 0.8 S.
Oh. Yeah. Oh. I know where is my wrong.
Where's your mistake?
My mistake is I use 0.1 T
Equals?
equals 0.8 S.
No weight?
Yeah.
So, this here, you can say, if you multiply it by 10, you get T plus 8S equals 4.905.
Yeah.
And then you can solve this. So what do you get? You get 7S equals,
3.92.
and then divide by 7.
Yeah, just 0.56.
Newtons.
Yeah.
And that plus T should be 0.981. So what's the other one?
0.42.
Newtons.
Yeah.
Yeah?
Yeah.
Did you get an answer, Gal? What went wrong for you, Khalifa?
Yeah.
Yeah, what was your mistake? Can you see what you did wrong? Yours is similar to this, except your turning point is down here. So you should have got T plus S equals that. And you should then have something, for your one, Khalifa, you should have something like 0.2 times S plus 0.9 times T equals 0.5 times 0.1 G. Something like that. Yeah? What answer did you get?
6 points.
Ah!
Um,
Can you me see what she did. Where's the mistake? T plus S equals 0.981. And then 0.1 T. Why 0.1?
It
It's
is
10 centimeters.
Yeah, but I asked you to put the turning point for you here.
You said here.
Oh, sorry, here. Did I? Okay, fine. So 0.1 T. Why 0.1? Because the distance from here to here is 0.7.
Here's
Oh yeah, but why 0.1 here?
here.
Yeah, but the distance from here to here, it's this distance multiplied T.
Okay, so what's the distance for this?
Here to here, 0.7. Here to here, 0.3.
Okay. So
no
this one, this distance.
This distance.
Multiply this
Yeah.
force should
Equals
equal
this
here.
distance multiply this force.
Why this distance? Why is middle point from middle point to here?
Huh? You're confusing me. I don't understand your question.
I understand that.
This is the turning point.
Yeah.
This force makes it turn this way.
Mm.
This force makes it turn this way.
Yeah.
How big is this turning force? It's 0.7 multiplied T
Okay, so 0.7 multiplied T.
equals this turning force, which is 0.3, because here to here is 80,
Yeah.
and here to here is 50. So here to here is 30.
Why is from here to here?
Because you want this force.
Oh yeah.
So this distance.
Oh that yeah, distance. Okay.
Got it?
I got it.
Are you sure?
Yeah, sure.
Okay.
I got confused.
Okay. Is this okay? Khalifa? Go. Ben? Summer? Are you sure?
Yeah, before it's clearly.
0.4.
Yeah, it's sure.
0.42, yeah.
Okay.
Okay, I'm going to go to the next lesson now, which is harder. Yeah.
Harder.
More of this.
More of this.
Yeah, more of this.